Today we're going to be discussing identifying and factoring out the greatest common factor, also known as the GCF. So anytime you see GCF, you should be thinking greatest common factor. And what is the greatest common factor? It is the largest number that goes into all of the numbers or variables that you are concerned with. So if, for example, you want the greatest common factor between, let's say, 36x squared and 54x cubed. For 36x squared, for the coefficients, you're going to want to kind of factorize it and then figure out what's the greatest term that's common between the two. And what do I mean by that? Well, 36 breaks down into 18 times 2, 18 breaks down into 2 times 9, and 9 breaks down into 3 times 3. 54, that's going to break down into 9 times 6, 9 breaks down into 3 times 3, and 6 breaks down into 3 times 2. So in common, they've got themselves some 2's, some 3's, and another 3. So the greatest thing that goes into both would be 3 times 3 times 2, which would be 18. Alternatively, had you literally listed out all of the factors of both, factor being a number that goes into them, then you would find that 18 is the largest factor that goes into both of them. Now, as for the x squared and the x cubed, recall that x squared is going to break down into x times x. X cubed is going to break down into x times x times x. So what do they have in common? 2 x's. So their greatest common factor would therefore be 18x squared, because they would have 18 would be the greatest common factor in common between their coefficients, and x squared would be the greatest common factor in common between their variables. Keep in mind also that if, for example, I was asking for the greatest common factor between 5y and 8z, well, y and z have nothing in common, and 5 and 8, the only thing they have in common is 1. So 1 technically goes into everything, but that is considered a trivial greatest common factor. Let's go ahead and look at another example. So let's say you wanted to factor 5x cubed minus 25x squared. Well, when they ask you to factor it, what they're asking you to do first is to pull out their greatest common factor. So what's the greatest common factor between these? Well, 5x cubed breaks down into 5 times x times x times x. 25x squared breaks down to 5 times 5 times x times x. So what do they have in common? They've got 1 5 in common, and then they've got 2 x's in common. So their greatest common factor is 5x squared. Then to figure out what would be left after you quote-unquote factor it out would be that you take both of those terms and divide it by their greatest common factor. What we're basically doing is undoing distribution, so at no point should you change the value of the problem. So if you pull a greatest common factor out front, you're going to have to divide each term by that greatest common factor. Then you would be left with, you still have the 5x squared. 5x cubed divided by 5x still leaves you with just a single x. Negative 25x squared divided by 5x squared leaves you with minus 5, and that would be your final factored form. You can also check your work by redistributing, so that's exactly what we're doing down here. So if you do 5x squared times 5x, you get yourself 5x cubed. 5x squared times 5, you get yourself negative 25x squared. So you know you did it correctly. Also keep in mind that by convention, if our leading term is a negative, we typically will also factor out that negative 1 just by convention. It's going to make it easier later on if that thing left in parentheses does not have a leading negative 1. So in particular, let's take a look at some examples. So between negative 8y and 2, their greatest common factor would be 2, because 2 goes into both of those. So I can factor out a 2, but I actually want to factor out a negative 2 because the negative 8y starts with a negative. So then I would have negative 8y divided by negative 2 for that term, and then 2 divided by negative 2 for the other term. Then when I simplify, I'm going to have negative 2, negative 8y divided by negative 2 leaves me with a positive 4y. 2 divided by negative 2 gives me negative 1. Now this division that I'm explicitly writing, I'm doing just for pedagogical purposes. Most people do that division in their head, but feel free to still write it out, especially whenever you are earlier on doing the factoring. Explicitly writing out each step can be very helpful. For this next one, between negative 3x and negative 7, while x and a constant, they don't have any variables in common, and actually negative 3 and negative 7 are both primes, so the only thing they have in common is 1. Since the negative 3x begins with a negative, though, we're going to pull out a negative 1 and then divide each of those terms by negative 1. Notice how I changed the minus 7 to plus a negative 7, just because I know that's going to make it easier for me to visualize what's going on when I do that division. Then I'll have negative 1 parentheses, negative 3x divided by negative 1 leaves me with a positive 3x. Negative 7 divided by negative 1 leaves me with a positive 7. So my final answer would be negative 1 times 3x plus positive 7 there. So let's do a little bit more practicing. So I would encourage you to go ahead and pause your video and try out these on your own and then compare with what we get. So to identify the greatest common factor between 108 and 24, I'm actually going to prime factorize both of these. So 108 I know would be 12 times 8. I messed that up. 12 times... Why am I blanking? Well, I know at least 2 goes into there. So 108 divided by 2 is going to leave us with 54. And then 54 divided by 2 is going to leave us with 27. And then 27 breaks down into 3, and it was 9, because 2 times 2 times 3 is 12, so 12 times 9, not 8. I was having a brain fart there. And then 9 breaks down further into 3 and 3. And the reason why I knew it was 2 went in there is because it's even, so I think I'm good to go there. Then for 24, I can break that down similarly, so I know that breaks down to 12 and 2, 12 breaks down to 6 and 2, and 6 breaks down into 3 and 2. Now why did I do all that work? To identify all of my pairs. So I've got myself a set of 2s, I've got myself another set of 2s, I've got myself a 3, and then we've got 2 times 2 times 3, so 12 looks like is their greatest common factor. Yes, that would be the greatest common factor between the two of those, because 24 does not directly go into 108, however 12 does. Similarly, between 62 and 31, you may already notice if I divide 62 by 2, that is 2 times 31, so it looks like 31 itself actually is the greatest common factor. So keep in mind that that number itself could be the greatest common factor for one of those two numbers, because everything goes into itself. Then I'm going to utilize the greatest common factor to help us factorize the rest of these. So between 18y and 36, 18 goes into both of those, and then what would be left? 18y divided by 18 plus 36 divided by 18. 18y divided by 18 will leave me with a single y. 36 divided by 18 leaves me with 2. For the next one, it looks like in terms of numbers, these coefficients, 5 is the greatest common factor because 5 goes into 10 and 5 goes into 15. In terms of variables, between x cubed and x squared, x times itself twice would be the greatest common factor, so x squared. And then I will divide both of those by that term I just came up with. 10x cubed divided by 5x squared will leave me with 2x. Negative 15x squared divided by 5x squared leaves me with negative 3. And I know that I will do it right because between 2x and negative 3, their only greatest common factor is 1. So I know it cannot be divided any further. For something like the next one, you're really going to want to keep track of one type of term at a time. So if I'm just focusing on the coefficients, between 30 and 12, their greatest common factor is going to be 6. For the next type of term, between x to the 4th and x to the 3rd, x cubed would be their greatest common factor because 3 x's do go into x to the 4th as well. Between y cubed and y squared would be their greatest common factor. And then between z squared and z would be their greatest common factor. And then what's going to be left? Well, we have to take each of these terms and divide it by what we just identified. to be their greatest common factor. And this is actually a good example of a problem where it's pretty helpful to explicitly show that division. And if you did this right, there shouldn't be anything left in the denominator after you simplified. If there is, that means you actually did not correctly identify the greatest common factor. So that first term remains the same. 30 divided by 6 is 5. X to the 4th divided by x cubed is x. Y cubed divided by y squared is y. Z squared divided by z is going to give us z. 12 divided by 6 is 2. X cubed divided by x cubed is 1. Y squared divided by y squared is 1. And z divided by z is 1. So this is our final answer. And I know I did it right because the greatest common factor between 5xyz and 2 is just 1. So it is indeed correct. And I'm actually going to make that box in a different color just for clarity. There. Okay, let's go ahead and take a look at another one here. And actually, let's not make that the exact same color. So for this next one, there's 3 terms, but the process is still the same. You're just looking at all 3 terms. So between 10, 6, and 8, their greatest common factor would be 2. Between a to the 3rd, a to the 4th, and a to the 5th, their greatest common factor, and actually let me change up the colors again. A to the 3rd, a to the 4th, a to the 5th, their greatest common factor would be a to the 3rd. And then for this last set, between b to the 5th, b to the 4th, and b squared, their greatest common factor would be b squared. And then I'm going to take all of those terms and divide it by the greatest common factor. So you can do this across 3 terms, no problem. A to the 4th, b to the 4th, 2a cubed, b squared. And of course I did not actually give myself enough room, so I'm just going to rewrite exactly what we just identified, but giving myself a little bit more room because that was silly of me. So we have 2a cubed, b squared, 10a cubed, b to the 5th divided by 2a cubed, b squared, plus 6a to the 4th, b to the 4th divided by 2a cubed, b squared, minus 8a to the 5th, b squared over 2a cubed, b squared. Okay, short of it though, we're still going to have 2a cubed, b squared, that greatest common factor out front. 10 divided by 2 gives us 5. A cubed divided by a cubed is 1. b to the 5th divided by b squared is b to the 3rd. 6 divided by 2 is 3. A to the 4th divided by a to the 3rd is a. b to the 4th divided by b squared is b squared. Negative 8 divided by 2 is negative 4. A to the 5th divided by a cubed is a squared. B to the 2nd divided by b to the 2nd is 1. And then we are just left with exactly, this is our final answer. So again, you don't have to explicitly write out those division by the greatest common factor like I did, but it can help. Now keep in mind it is actually possible for the greatest common factor to be a full term in parentheses, and this is actually going to kind of segue into our next video pretty nicely. So in this, keep in mind that really is a 5 times an x times a, in parentheses, 2x plus 3, and the next term really is a negative 2 times in parentheses a 2x plus 3. So in this case, the greatest common factor can actually be 2x plus 3 in parentheses. Why not? So then if I factor out a 2x plus 3, what's going to be left? Well, that's 5 times 2x plus 3 divided by 2x plus 3 minus 2 times 2x plus 3 divided by 2x plus 3. And lo and behold, what happens when I divide 2x plus 3 divided by itself? Those are both going to make 1. And what I'm left with is 2x plus 3 times 5. Oh, that was a 5x, not a 5. 5x minus 2. I just mistranscribed the problem. Instead of writing 5x, I wrote a 5 by itself. That 5x is still there. Similarly, I can do the same thing with this next term. So here, 3 minus m and 3 minus m is what they have in common, but 5 and 9 otherwise don't have anything in common, and m and n don't otherwise have anything in common. So 3 minus m is their greatest common factor, and what's going to be left? This whole thing divided by 3 minus m. And then this whole thing divided by 3 minus m. When I do that division, anything divided by itself is just 1. So what you would be left with is 3 minus m times 5m plus 5n. And if you notice, the general pattern on this is basically one of these parentheses ended up being that parenthesis they had in common, and the other parenthesis ended up being those things they did not have in common. And that pattern is actually going to bring us into factoring by grouping, which we'll be going over shortly. But in short, for any of these, what you want to do is identify your greatest common factor, whatever it is, and then what you're going to be left with is that term divided by the GCF plus the other term divided by the GCF for as many terms as you want until you get to the last term divided by the GCF. As long as you have divided every single term by that greatest common factor, you will have factored out that greatest common factor correctly.